We could just leave it at that. Okay, actually with right triangles is what I'm going to put. Okay, that says with right triangles. I should have written that a little nicer. I'm sorry, I was being lazy and trying to squish it in. With right triangles. Because we're going to do another version again when we get back from break. And then we're going to do the, so I can find the exact value. So I can use the unit circle. To find, and we may use this I can statement a number of times, the exact value of an angle based on a reference angle. And we're going to do this a lot in a lot of different modalities and do a lot of different contexts. Okay, so just know that we're you're going to see a lot of, it's going to kind of keep repeating for a while, which is nice because then you get the hang of this. Okay, I'll give you a minute to write that out. I want to make sure I've got okay, maybe. See if I've got it. I'm just making sure I got my words. Nope, it's not that one. Okay, I've got the right set of notes in front of me now, I think. No, it's not the right set of notes. Oh yeah, it is. Okay. Sort of. This is my, oh, I know which one it is. I know what I gotta pull. It says this one. Okay. So again, this is kind of like a preview lesson. That's what I usually do with this one. And of course, I don't have any of that on it. All right. Let's see. Oh, there we go. Finally got one that I have on it. All right. So a unit circle is exactly what it seems like. It is a circle whose radius is 1 unit. All right. So we've got my, I'm going to draw a circle on here whose radius length is 1 unit. So that is like 1 unit, but it's, we call it R for radius. And that could be whatever the unit is, right? Our 1 unit just is just a ratio. We've got 1 on there, okay? Or I could put that the 1 is right. It's also 1 right there, right? Because that's the radius out to that edge of that circle. I am also going to go ahead and draw a triangle in there. So now you can hopefully start seeing our right triangle appearing, okay? And I have it tilted one direction. It can be tilted any direction. I think the ones you guys have on your circle are tilted because the ones you attached are like more tilted like that, right? The ones, and they're more decoration than anything else for our unit circle, but they work, okay? They work for what we need. All right, and then this is out X and up Y. And we're gonna, our reference angle is right in there, that's our theta. And we're gonna work with some standardized reference angles in the unit circle. You'll notice we had the 30, we have the 60-degree triangle, we have the 90-degree triangle. That's mostly what we're gonna see, okay? So for any angle in standard position with measure theta and point P, X, Y on its terminal side, and basically they're talking about the radius right here. What does that little formula right there remind you of? Does that remind you of any formula that we've had before? Does anybody have any guesses? What does it kind of look like? What does it kind of look like? Anybody got a guess? I'll give you a hint. Mrs. Ballard's, there we go, Annalisa, good job. Mrs. Ballard's favorite mathematician. It looks like the Pythagorean theorem, right? Because it's based on a right triangle, right? If I had just written it r squared equals x squared plus y squared, all we did was take the square root. It's totally the Pythagorean theorem right there, okay? So that it's all interconnected, all right? What I'm gonna do now is, based on that, okay, I am going to try to find my ratios, my 6 trig ratios, based on the triangle that's there, okay? So we know sine is opposite over hypotenuse. What would the sine of this triangle that we drew here be, based on the letters? So tell me in the chat, what do you guys think the sine is of that triangle? Do we not remember? Or we having delay today? Oh, there we go. All right, I shouldn't have written the 1 there. Let me just call that R. Okay, it was my mistake to put the 1, but you guys are all on the right track. Okay, I'm going to adjust the 1 to be the R. All right, so we're going to say that this is Y over R. Okay, all right, now that we've got that adjusted, what's the cosine using the X, the Y, and the R? So what would your cosine be? Can you help me out with that? Remember, cosine is adjacent over hypotenuse. So what's your adjacent over there? We go. We're getting it now. All right. We've got that down. So we've got that that's X over R. And then that means that the tangent has to be Y over X. Now, our reciprocals, we're just going to flip them, right? So cosecant would be R over Y. Secant would be R over X. And cotangent would be X over Y. So we can still write these in terms, we can write those trig ratios in terms of any triangle. Okay, just a little review of sine, cosine, and tangent without numbers, right, with variables. So we're going to learn a little bit about trig identities today. I'm going to learn these specifically to talk about them with the quadrant angles. Okay, so by quadrant angles, I mean what's going on the axes. Okay, because there's no other way to do these except on the ones on the axes, and these might pop up in the homework. So we are going to look at these a little differently than we're going to look at the rest of our unit circle. Okay, so we're going to start with that, and then we're going to do the triangle part of the unit circle. So cosecant is the reciprocal of sine. So we would write 1 over sine. And I know I was really bad and did not like write an X there. It really should have an X. Cosecant of X would be 1 over cosine of X. Those are the reciprocal identities. Now, tangent and cotangent, it isn't going to help me to have 1 over cotangent because I'm not going to have enough information about that. I want them written in terms of sine and cosine. So we're going to use what we call the quotient identities. These are reciprocal. And we're going to write, these will repeat themselves throughout what we're doing in trig. These are going to be called the quotient. Well, if it's called quotient, that means I'm dividing something, right? So tangent is the sine divided by the cosine. Cotangent is the cosine divided by the sine. Write that down, and I'm going to prove to you that that's correct, okay? Okay, so let's prove to us that the tangent works, all right? And what I'm saying is a correct formula there. Let's just take our cosine and divide it by the sine. So we have X over, oh, sorry, it's the sine divided by the cosine. I'm writing it wrong. The sine, Y over R, divided by the cosine, X over R. When we have a complex fraction, we flip and multiply. These cancel, and I get Y over X. So do you see? They're all interconnected still. Okay, you can manipulate them kind of the way you want to be able to get what you need. Okay. All right, so we know that that works. So our unit circle, if I was to actually write the coordinates 1 unit out when on the unit circle, I would see that this first coordinate here at 0 degrees or 0 radians, or when I loop it around, it'd be 360 degrees or 2 pi, okay, is the coordinate 0, 1. The one up here at 90 or pi over 2 is 0, 1, is 0, sorry, I said 1, I meant to say 1, 0 here, 0, 1. This one here at pi or 180 degrees is negative 1, 0. And down here at 270 or 3 pi over 2 is 0, 1. So when we are doing this, okay, our cosine comes first in the coordinate and our sine is second. So if I was just going to put this in the calculator, which we'll do this in a minute to just prove it to ourselves, okay? If I said cosine of 0 in the calculator, it should be 1. Okay, so we'll test it out for our sine coordinates. So when I do sine of 90 or pi over 2, I'm going to read my y coordinate, which is 1. So sine is always the y, okay? 180 over or pi, my sine is going to be 0, okay? 270 or 3 pi, my sine is going to be negative 1. And 360 or 2 pi or 0, my sine is going to be 0. So let's take that for a minute so you believe what I am saying, and let's put it into Desmos really fast, okay? So I'm just going to demo it in Desmos. All right, and I believe Desmos is in degrees, right? Let's double check. My thing is acting dumb. There we go. Oh, we're in radians. I'm going to switch it to degrees, okay? So I'm going to go sine of 90. Look at what I got. Sine of 180. I got 0. Sine of 270. I got negative 1. Sine of, what was the other one? 360. 0. Or sine of 0 is 0. Okay? Let's switch it to radians really quick so you can see that happening. Okay, let's say that instead of sine of 90, it was sine of pi divided by 2. Look at it, still 1. Okay, sine of pi, still 0. Sine of 3 pi divided by 2, still negative 1. And then sine of 0 or sine of 2 pi, still 0. Okay, so it worked, right? The coordinates worked, right? So let's try this for cosine and just use our coordinates, okay? So the cosine is the x coordinate. So I'm going to do the first one or two, and then you're going to help me out with the last one or two in the chart, okay? So I've done a lot of talking. So I'm looking at my x coordinate here. The cosine of 90 would be 0. I'm looking at my x coordinate on pi. My cosine would be negative 1. So can you tell me in the chat, what's the cosine of 270? So what's the x coordinate at 270? Can you guys give me that in the chat? So I want to make sure we're paying attention. All right, excellent work. It is in fact 0. Good job. Okay, then 360. What's the cosine or the cosine of 360? Can you tell me that in the chat? All right, I'm seeing lots of ones. Nice work, everybody. All right, so now here's the thing. We can get the sine and the cosine really easily. We can't read the other ones just off of that. So that's where these trig identities come in, okay? So for tangent, what I'm going to do is I'm going to take the sine and I'm going to divide by the cosine, all right? So I know that I'm going to go to 90, and I'm going to erase a little bit because I've got too much of a mess there, okay? And I am going to divide my sine 1 by my cosine 0. But there's a problem there. Are we allowed to divide by 0? When we divide by 0, that's something that's undefined. So I'm just going to write undefined for that one. Okay. All right. For this one, I'm going to take my sine divided by my cosine. I am allowed to have 0 in the numerator. So 0 divided by a number is equal to 0. All right. I'm going to go here. So my sine negative 1 divided by 0. So what's negative 1 divided by 0 going to be? Can you tell me that in the chat? What am I going to write instead? Because if we divide by 0, our paper will explode. Did you know that? So we want to write as quickly as we possibly can, undefined, so our paper doesn't explode, right? That's the rule on divide by 0, okay? All right, yes, quickly get undefined in the chat because you don't want your papers to explode. All right. The next one, we're going to go 0 divided by 1, which that's okay. That is equal to 0. Okay. So if on your homework it came up and said it wanted the tangent of 180, you would tell me that that is equal to 0. Okay, because we went and I looked at our chart. Okay, so for a while you're going to rely on the chart, and then we will get better at this as we go. But that's where we're starting. All right, let's do the cotangent really quick, because I've already got tangent up there. Remember, for cotangent, I'm just going to flip the reciprocals. So the reciprocal of this piece right here would be 0 over 1, or just 0. This one would be -1 over 0, or we would have to write undefined so our paper doesn't explode. For this one, we've got 0 divided by -1, which would be 0. And this one would be 1 divided by 0, or undefined. I'm going to give you a minute to catch up. All right. We're now going to do cosecant and secant. And remember that those are the reciprocals of sine and cosine. Okay, we already got the sine and cosine row. It's right there. I'm going to do, so we know that cosecant is 1 over sine. So basically, I'm going to take 1 and I'm going to divide it by whatever I have up here, which is a 1. So that first one's 1. I've got 1 and I've got to divide by 0. So this one ends up to be undefined. Okay. I've got 1, and I'm going to divide by -1. That's going to turn out to be -1. I've got 1, and I'm going to divide by 0, so that's going to be undefined. Okay. Actually take a minute before I do it for you. See if you can get the secant row. You're going to do the same thing we just did with sine, but you're going to use cosine instead. So everybody take 1 minute. I will be quiet for that whole minute. Find the secant row. All right, we're going to do a quick check. And I'm not going to do 90 first, okay? I want to do -180, okay? So tell me, what did you get for the secant of 180? So what did you get for the box I highlighted in yellow? I'm just checking to see if we're understanding here. All right, it looks like we're on the right track. I don't doubt it, because you guys are my superstars, right? So keep it up. So we've got 1 divided by -1, which is -1. All right, and then this one here, we would have gotten, let's see, we're doing 1 over 0, so it is undefined. 1 divided by 0, again, undefined. And then 1 divided by 1, so that's just going to be 1. Are we curious why we keep getting those undefined things? I wasn't going to do this with today's lesson, but let me show you really quick, okay? Because I want you to see that this also, just like any function, like an x squared or an x cubed or a rational, Trig has graphs, just like the other ones do. Okay, so let's look at Desmos. I don't want to spend a lot of time on this, but I want you to just see this, and we're going to make more connections to this later on. But this is, again, we're kind of previewing the heavy trig today. So sine of x, that's what sine of x looks like. It's a wave, okay? I'm going to put cosine of x up there. Cosine of x. It's a wave too, but it looks like it's kind of shifted a little bit, right? All right, I'm going to take cosine off. I'm going to hide it for a minute. I'm going to do cosecant of x. Look at how it's reciprocal of sine, right? I flipped my signs, but check out what happens. Do you see how there's an asymptote there? There's a vertical asymptote going on. So that's why we get undefined, because there's a vertical asymptote. Okay, let's look at cosine and secant. Again, it's the reciprocal, it's flipped, and I have that vertical asymptote going on. Okay, let's look at tangent and cotangent. Tangent and cotangent are their own beast. There's tangent. Okay, typically when we first the graphing calculator really squishes this one down. Desmos does a slip, but it looks like a heartbeat sometimes. Heartbeat monitor. But again, it looks like we've got some asymptotes going on there, right? You can see that there's something going on there. And then cotangent, it just flips it the other way, right? Technically it's flipping across the x-axis, but you can see that this part, actually no, it's not. Oh yeah, it is. This part ends up down here and this part ends up there. So that's what's going on. Okay. All right. That was my quick sidetrack. Let's get into the actual circle. Okay, I know I'm excited to do the circle. Okay, so we're gonna start small. Okay, I'm gonna teach you one piece of it, and then we're gonna build onto it. Okay, it's kind of like learning how to read, right? We start with learning how the letter sounds, and then we build on to learning words. Right. So we're gonna start with the letter sounds, which are gonna be negative and positive signs. So we're supposed to state whether the value of each function, so the final answer is negative, positive, 0, or undefined. 0 or undefined are only going to be these ones that are on the table. Okay. The negative and positive comes from the circle. So let's start with this circle. Hopefully you have it all nice and labeled. Okay. So on that orange outer ring, okay, there's a mnemonic device there to help you remember it, because at some point we will wean you off of the circle. Right? So the mnemonic device is all students take calculus. It's also my subliminal message to make sure you take calculus next year. Okay. So that's just the way to remember it. What it means is that in quadrant 1, no matter what trig ratio I do, all of the values are positive. So if my triangle reference angle lands in quadrant 1, it's positive no matter what. If it lands in quadrant 2, only the sine and cosecant are positive. Everything else is negative. Okay. If it lands in quadrant 3, only tangent and cotangents are positive. Everything else is negative. All right. If it lands in quadrant 4, cosine and secant are positive. Everything else is negative. All right. So that's where we're at. So all we're going to do is use the orange ring right now, and then we will add on to it here in a few minutes. Okay, I'm going to do a couple with you, and then I'm going to ask for some help in the chat. Okay. So I'm going to zoom out so I can kind of see both at the same time. So sine of negative 135. So notice we have both degrees in radians. I need to figure out what negative 135 is coterminal with. I could try to count it backwards if I wanted, or I could subtract from 360. So I'm going to use subtract from 360. So I'm going to do 360 minus 135, and that gets me 225 degrees. So I know that I'm landing here. Okay. I want the sine. It's telling me that the only thing that's allowed to be positive is tangent and cotangent. So I know that the sine is going to be negative, and it's fine to just write a minus and a plus for these. This section is just building us to what we're actually going to see on the homework. Okay, we're just learning that one little piece. All right. I noticed that 405 degrees is not on my unit circle. So I need to figure out the coterminal angle, just like we did in the other day's lesson. I'm going to subtract 360. So 405 minus 360. Let's see. Oh, I went the wrong way. 405. I think it's 45. That's what I would have guessed. 45 degrees. Should be looking. I have it written in my notes, actually. All right. So I'm at 45 degrees. At 45 degrees, everything is positive. So I know that cosine of 405 is positive. All right, we're going to do one more together. Okay. It doesn't matter. These work the same whether you have radians or degrees. Okay, and we're going to flop between the two. Okay. So tangent of 315, that one's on my unit circle. It's right here. And in quadrant 4, I know the only thing allowed to be positive is cosine and secant. So in quadrant 4, I know that tangent has to be negative. All right, you're going to help me now. You ready? So I'm going to go, actually not yet. You'll help me starting on example 5. Cotangent of 2 pi is a little bit trickier. Cotangent of 2 pi lands on a quadrant angle. So when we land on a quadrant angle, we shift gears. We're going to come up and look at our chart. We said cotangent. Cotangent of 2 pi, notice, is undefined. So we would write undefined for that one. All right, you're going to help me now. So cosecant of pi over 4. So locate pi over 4. And then tell me in the chat, is the cosecant of pi over 4 going to be positive or negative in quadrant 1? Tell me what you think. All I need is a plus or a minus. All right, so we know that it is positive. Good job. Okay. Secant of 11 pi over 4. 11 pi over 4 is not on our unit circle. What am I going to have to do first before I try to do figure out where it's at? What do I have to do first? Can you help me out with that? See if you remember what we were doing the other day. Remember, 1 full revolution around. What is that going to mean in the context we have? Okay, so Natalie's suggesting 360. If we're in radian world, what's 1 full revolution around? You guys tell me that. So it's 1 full revolution around in radians. In degrees, it's 360. What is it in radians? Okay, good. All right, so we know that it's got to be 2 pi. And then the other day we made in that left-hand column, we made a list of what 2 pi looks like in over 4 world, right? And if we don't remember that, that's okay. We can recalculate it. We know that 2 pi, we want it to be over 4, so we've got a common denominator. We would just have to multiply both by 4, and we would get that it's 8 pi over 4. Since 11 pi over 4 isn't on my unit circle, I'm going to subtract it. So 11 pi over 4 minus 8 pi over 4 equals 3 pi over 4. So really I am looking at the secant of 3 pi over 4. So, okay, that would be right here. Okay, so tell me in that quadrant, is secant positive or negative? I only need just a sign in the chat. So is it secant going to be positive or negative in that quadrant? All right, excellent work. Okay, I want to talk about one more way to do that one really quick. Okay, so let's talk about this. I could have counted this as well. Instead of, if I didn't remember the subtract from 2 pi, I could count this out. So on my unit circle, I'm going to count to 11 pi over 4. So I know that this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4. So I can count the wedges as well. Okay, so that's another possibility of how to get there. There's going to be like, on these, there's like 10 different ways to do each problem. Okay, and depending upon which teacher you talk to, everybody's going to do it different. Okay, they're all good. All right, you just got to find one that works for you. All right, tangent of 90. Tangent of 90, we need to go back and look at our chart, right? Because 90 is on a quadrant angle. So I'm going to go back up to my chart. Tangent of 90 says that it is equal to 0. All right, and then we've got negative 45. So there's 2 ways I could do that. I could do my subtract 360. So 360 minus 45, or I could just count backwards 45 degrees. 145 degrees. So I'm going to end up at 315 no matter what. All right, we're looking at cotangent in this ring. Am I going to be positive or negative? Can you guys tell me that? Should I be positive or negative for cotangent in quadrant 4? All right, we're going to be negative. Excellent work. All right, so that was our baby step. We're ready for the whole problem now. Okay. These ones, you're going to have to get used to this. It's going to ask for what we call exact value. All right. So when you see these words exact value, that means you cannot put it in your calculator and get the decimal point. It will be marked wrong. Okay, so no calculator decimal points. Okay, it is exact value only. So that means it's going to be left with radicals or maybe some fractions. Okay, I can do number 7 again. So number 7 is, I'm glad you asked. Okay, so that's exactly what I want you guys to do when you're not understanding. That's the bonus of having me right in front of you, right, rather than watching a video. So example 7 says tangent of 90. Because this one is on a quadrant angle, it's on like the XY axis. I know I've got to go to the chart because my my negative positive is not going to work. So I went to the chart and I looked at the tangent of 90. What did I do? Did I totally write it down wrong, you guys? It's 1 divided by 0. It was undefined. Did I write it? Did I totally do it wrong? I did it wrong. I picked the wrong thing. Thank you for catching me, Mariana. It should have been undefined. So everybody fix that. It was undefined. Okay. Nope, thank you for picking up on that. Sometimes I just blow it, right? Okay. It's okay. We're all human and make mistakes, right? So Mrs. Ballard makes them too. All right, let's take a look now. I want to use something that's not a pink, a red, or a blue. We're going to actually figure this out from the unit circle now, and our triangles are going to come into play now. So we're going to connect this back to our 30, 60, 90, and 45, 45, 90 triangles. And hopefully you noticed that those are the triangles and their multiples are what are on our unit circle. Okay, so, and then each one of these lines is color-coded to one of the triangles, right? Anytime I see a blue line, I know I'm working with the 30-degree triangle or the blue triangle, okay? Every time I see a red or a pink line, I know I'm working with 45 and the pink triangle. And ignore my pink lines on my quadrant angles. I keep forgetting to edit the picture. They should be black. Let me just trace over them. Okay, those should be black lines because they're quadrant angles, okay? All right, and then every time I see a green line, right, I am going to work with the 60-degree reference triangle. All right, so the first thing I'm going to do is identify the sign, just like we were doing in the last set of examples. So I'm going to go to 150. I am noticing that 150 is here. Okay, it's in quadrant 2. In quadrant 2, is cosine going to be positive or negative? Tell me in the chat. So is cosine positive or negative? All right, perfect. I'm going to write that down first. So I'm going to say negative. Now, I notice that this is on my blue line, which means that my reference triangle is the blue one, and cosine is the adjacent over the hypotenuse. So I'm going to write down 3 squared of 3 over 2. There is a lot of work to that, but look at how much we wrote down. It looks like you're basically copying somebody's answers, right, when we write it down. There's a lot of thinking, okay? So you have to get used to the fact that you're doing most of your thinking on the unit circle, and I understand that with these, okay? That I'm not going to see a whole lot of written work. That doesn't mean copy your neighbor, okay? Because there's not a lot of written work, and it's easy to copy your neighbor. Don't do that. Okay, you need to know this and you need to understand this really, really well, okay? Because when it comes time for calculus, if we don't know this well, we are toast, okay? Because trig has got to be like that, okay, when we get there. You're going to get there, I promise, okay? And we're going slow because it's the first day, okay? You want to get good enough because we're going to eventually play a game with us, okay? Not today, but we're going to play a game with it, all right? So you want to make sure you're getting good at this. So cosecant of 135. Let me use a neutral color again. 135 is here. Okay, first thing is we write down our sign. So cosecant of 135, is it positive or negative? All right, perfect. It is positive. I'm seeing a lot of positives. Okay. I am on a pink line, so I'm going to go to the pink triangle. I know that cosecant, ooh, interesting. We haven't had to do just cosecant by itself very often, right? Is going to be the hypotenuse over the opposite. Hypotenuse over the opposite for cosecant, right? The reciprocal of sine. So I would write down square root of 2 divided by 1. So square root of 2 divided by 1, which is just going to be square root of 2. I purposely write my plus sign because it's a checkbox in my head that says I checked off that I know whether it was supposed to be positive or negative. Okay, it doesn't have to appear in my final answer. When you do delta math, don't put the plus sign in because it's not going to probably accept it. Okay. All right, let's do sine of 240 together here. So sine of 240. I'm going to go here to quadrant 3. Okay. The sign would be negative because we're in the orange ring. It would be negative. Only tangent and cotangent allowed to be positive. And then I would go to the green triangle. My green triangle, I want sine as opposite over hypotenuse. So I would write down square root of 3 over 2. Now, we haven't had to do a lot of rationalizing yet. It's coming, I'm sure, in the next few. Okay. So it might not be just this simple. All right. They do build and get a little bit tougher than that. Okay. Let's look at tangent of 5 pi over 6. All right, so I'm going to find 5 pi over 6. Can you guys tell me what quadrant is 5 pi over 6 in? Is it quadrant 1, 2, 3, or 4? Oh, look at those Roman numerals. Nice job, Abby. That made my teacher heart smile, but it's okay. I told you the other day you could just do the numbers. Okay, so we know that it's in quadrant 2. So you guys all found it. It's here. Okay. And doesn't matter if we do radians or degrees. We know that in quadrant 2, tangent is negative. So I'm going to start by writing negative. Okay. What color triangle is my reference triangle right now? Can you tell me that? I'm checking to make sure we understand this right now. So what color is my reference triangle? All right, perfect. So we know that it's a 30 degree, right? Because my reference triangle is the blue, which is 30 degrees. All right, so we've got that this, and then we're going to find the tangent. Tangent is opposite over adjacent. So I've got 1 over square root of 3. Unfortunately, I can't leave it like that, right? We're not supposed to have radicals in the denominator. So we're going to rationalize it. So my final answer would be negative square root of 3 and then over 3. Remember when I taught you, we reviewed radicals and I said you're going to want to be able to do this shortcut? This is why. Because when we're doing unit circle, we have to do this a million billion times. Okay, maybe not that many. Maybe like 100 billion. Okay. All right, but we're going to have to do that rationalizing all over quickly. Okay. All right, let's try it again. So cotangent of 5 pi over 4. Okay, so we're going to go to 5 pi over 4. I'm just going to finish it up. I know we're going to run over by just a couple minutes, but if you guys can bear with me, we can get it finished. Homework is really short. It's like a 20-minute homework, and you don't have to watch any more video today. Okay, so it should be short and sweet the rest of the period, and then we get this done. Okay. All right. Cotangent of 5 pi over 4. It is in quadrant 3. Can you guys tell me the color of, or actually, before we do that, 5 pi over 4. I know that cotangent is going to be positive. Now, can you tell me the color of the reference triangle, please? What color is the reference triangle? It's pink, Alexis, but thank you. It might look purple on mine. All right, so it's pink, blue, and green. All right, so, and hopefully you have yours, right? Because it should be pink on yours too. All right, so it's pink. So I'm going to go to, let's see, cotangent would be the adjacent over the opposite. So adjacent is 1, opposite is 1, so I get just positive 1 on this. All right, 8 pi over 3 is not on my unit circle. So I can either add or subtract 2 pi, or I can count the wedges. I'm going to count the wedges this time. How's that sound? Okay. So I'm going to go do my pi over 3. So here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3 lands me here. Okay. So I'm in quadrant 2. I know that secant, according to my orange ring, has got to be negative. What color is my reference triangle, everyone? What color is my reference triangle? Perfect, it's green, right? Which means it's a 60-degree reference triangle, right? So I am going to do, let's see, secant is the hypotenuse over the adjacent. So hypotenuse is 2, adjacent is 1. So my final answer would just be -2. Okay. All right, let's see if we can get through these last few. I'm going to go a little bit faster. Okay. So cotangent of 315. 315 is in quadrant 4. Okay. Quadrant 4, cotangent would be negative. We have a pink reference triangle. Okay. So my cotangent on the pink reference triangle would be the adjacent over the opposite. So I would get 1 over 1 or just -1. A lot of your answers are going to look similar to one another because there's only so many possibilities with the 3 triangles. Okay. All right, 2 pi over 3. So 2 pi over 3 is in quadrant 2. All right. Secant in quadrant 2 looks like it's got to be negative. And then it looks like I'm using the green reference triangle. Secant of the green reference triangle would be the hypotenuse over the adjacent. So it looks like 2 over 1 or just -2. All right, last one. 11 pi over 6. So I'm in quadrant 4. Cosine in quadrant 4 is allowed to be positive. And then we're on the blue reference triangle. The blue reference triangle gives me for cosine adjacent over hypotenuse. What happened? It's not right. There we go. So I'm going to get square root of 3 over 2. Okay. We didn't do a whole lot of rationalizing, but it's going to come up in the homework. Okay. The homework is Delta Math. All right. So it should self-check. It's, I think, between like 16 and 20 problems is what I want you to try because I want you to get good at this with the triangles. Okay. But Delta Math said it was like a 20-minute assignment when they put their little timing on it. All right. Are there any questions, comments, or concerns as I switch to the joke of the day? Because I can't send you on break without a joke of the day, right? Okay. My advice for the rest of the day after we're done here is you do need to go take a quick break. Enjoy the sunshine because apparently next week it's supposed to be cold over break. Where did the joke of the day? Math jokes. Here we go. Okay. And we're going to share the right way.
It was a...
Okay, hold on. Here he comes. I'll rewind.
Okay. Hey guys, now it's time for another joke. Why did the student get upset when his teacher called him average? It was a mean thing to say. And I'll be here only because I live here.
All right, everybody. I hope you guys have a wonderful break. Please take a break. Triad does end the week we get back. Take a break. Do something fun for yourself. Be with your family. Okay, get some sunshine. All right. And I will see you on the Monday we get back. Remember, the bell schedule is different. For you, we still all meet at 9:15. We all check in every day at 9:15. Okay. If you've got any questions or anything over the break, let me know. Okay. Have a good day.